Let's now continue writing our smart contract functions. The next function is the swap exact tokens for tokens. This function will take in an amount in, which is the amount of tokens that we are sending for the swap, an amount out min, which is the minimum amount that we accept to get of tokens, and the path, which is the array with the two token addresses. So we begin by calling the transfer from function on the path 0 token, so on the token that I am sending for the swap that I want to provide, and you see that the token is sent from the message sender to this contract with this amount. After that, we call the approve function on the token to approve the Pancake router to spend this amount of tokens in behalf of the smart contract, because now the tokens are owned by the smart contract. After the Pancake router is approved to spend the tokens, we call the swap exact tokens for tokens, and we provide it the arguments. So the arguments will be the amount in, the amount out min, the path of the tokens, message sender will be where the exchange tokens will go, and this will be the deadline. After that, we need to get the amount of token B that we are getting for our token A, and then we emit a swap transfer event. Next function is called swap exact tokens for BNB. In this function, we are going to swap an exact amount of tokens for a calculated amount of BNB that will be equal in value with the total value of the amount in of tokens that we send. So we begin by sending the tokens to the contract to do the swap. After that, we initialize an address array of two elements. The first element will be the token and the second element will be BNB. After that, we call the approve function on the token. We approve the Pancake router to spend this amount of tokens, and we call the function swap exact tokens for ETH, providing the arguments amount in, amount out min, path, so the path with the tokens, the address where the tokens will go after the exchange, and the deadline. And we finish by calling the get amounts out function, which will give us how much BNB we will get for this amount of tokens. At the end, we emit a swap transfer. Keep in mind that the tokens are not sent from the Pancake router. We do this just to simplify it a bit, because for us, as it looks right now, the tokens seems like they are sent from the Pancake router, but I did an explanation in a previous video where I showed you that the tokens are sent to the user from the Pancake pair contract and not from the Pancake router, because the Pancake router will interact with the Pancake pair, which will actually do the swap and then send the tokens back to the message sender that called this transaction right here. Let's compile our contract so we know that everything is fine and we have no errors. We have no errors, so we can continue writing our smart contract. So the next three functions will still be swap functions, and they are pretty similar to the ones that we already talked about, but there is one big difference, and the difference is that in the first three functions, the user will give an exact amount of token in for another token. So the user will specify the exact amount he wants to provide, and the app will calculate how much of token out the user would get for that amount of token in. The difference in these three functions is that the user no longer provides how much token in he will send for a token out. What he does now instead is provide an exact amount of token out that he wants to get, and the app will calculate and will let him know how much of the token in he needs to provide. So it's like we know how many tokens we want to get, but we don't know how much we need to pay for them. And here we know how much we want to pay for a token, but we don't know how many tokens we will get after the exchange. So you see that this function is called swap BNB for exact tokens, and it's very similar to the first one here, which is called swap exact BNB for tokens. So hopefully you can already understand what I'm talking about from the naming of the functions. So here we are swapping an exact amount of BNB for a calculated amount of tokens. And here we are swapping a calculated amount of BNB, so we don't know the exact amount yet, but we do know the exact amount of tokens that we want to get. So we start by initializing the path array. we approve the Pancake router to spend our amount of BNB that we sent, which will be sent through the message.value global variable. Then we call the swap ETH for exact tokens on the Pancake router. We provide the value as the message value, and then we give it the arguments. So you see that there are two arguments. The first argument will specify how many tokens we want to get, so the amount out, and the token out that we want to get, because we already know that the token in is BNB. So we're giving the amount out, the path, the address where the tokens will go after the swap, and the deadline. If we have a look over this is wrong, because we are trying to calculate how much BNB we are getting for a token in, but as I already said, this is not how this function works. We already know the amount of BNB that we want to get, so here basically we will want to calculate how much of the token in we will need to send, but we no longer need to do this. Firstly, here we will need to call the getAmountsIn function and not the getAmountsOut. The getAmountsIn function basically is saying that I am sending that I want to get this amount of the second token in the path array. So please tell me how much of the first token from the path array I need to send to get this amount out. But there is no reason to do this on the smart contract side, because when this function is called from the front end, we already required to have a message value. This one needs to be called from the front end, calculate how many BNB the user has to send. So the user, when he calls this function, he already sends the value of BNB that is required for this amount of token out. Let me show you a quick demo on BSCAN of how these two functions are working. So you see that here we have the getAmountsOut function that we used until now, and I am providing two token addresses in the path array. The first one is from wrap BNB, and this is the cake token. I am given an exact amount as the amount in for this function, and this is 2, and this is basically saying I'm providing 2 as the amount in value, and amount in will always refer to the first token here, because the first token is the token in and the second token is the token out. So you are saying I am providing 2 of token in. Token in is wrapped BNB, so you're saying that you are providing 2 wrapped BNB. I am running the function and I get as return the amounts array. The first element will be how much of token in we provided, and we said that we provided 2. And the second element from the array is the value of token out that we are getting. We are getting this amount of cake tokens for 2 wrapped BNB. Now for the getAmountsIn function, we have the same array with the same tokens in the same order, and I am providing instead this number here as the amount out. If it says that this is the amount out, you will know that you are now providing this amount of the second token from the array, because this is the token out. So when I run a query and I get as response the amounts array, the second element, which is the amount out, is how much we provided, so the exact amount out that we provided, and the first element will be 2, which is basically how much wrap BNB we are getting for this amount of token out. Let's continue with the next function, which is called swap tokens for exact tokens. You can see that this function has 3 parameters. The first one is the amount in max, the second one is the amount out, and the third one is the path. We know what the amount out and what the path are, but what is this amount in max? Here you need to say how much do you agree to give in exchange for the amount out that you provided. So let's say that I want to get 10 link tokens. I have to give 100 test tokens in exchange for them. So this is how much will cost me to get 10 link tokens, and I agree to this number. Then this basically says that I agreed to this number, please execute the transaction only if I don't have to spend more than 100 test tokens for it. If the value of link tokens goes up and now 10 link equals to 110 test tokens, I don't want to swap because this costs more than I agreed on. So let's say that you want to swap 10 link tokens as the token out, and Pancakeswap says that you need to pay 100 test tokens. But in 2 or 3 seconds before you click the swap transaction, the value of the link goes up and now it's more expensive. So because when you click the button, the agreed amount in max was 100 test tokens, but when the transaction was run, the value that was needed as the amount in was bigger than 100, the function will no longer execute because it's higher than the amount in max that you provided for the function. You as a user don't provide that. Basically, the app makes the calculations and shows you the value on the UI, and you see it, and by clicking the button you basically agree on that value. So the function is pretty simple. We have to transfer the tokens from the user to the contract, approve the Pancake router to spend the tokens with the amount in max, and then let the Pancake router execute the swap tokens for exact tokens transaction and emit a swap transfer event with the following arguments. And then the last function is the swap tokens for exact BNB, where we provide the token that we are sending for the BNB, the amount maximum that we agreed on to send as the amount in, and the amount out of BNB that we want to get. So we are transferring the token to the contract, initializing the path array. The first one is the token, the second one is the wrapped BNB. We approve the Pancake router to spend this amount of tokens. We let the Pancake router run the swap tokens for exact ETH function, and then after the transaction is done, it will emit a swap transfer event from the Pancake router to the message sender, token in and token out, amount in and the amount out.